Welcome to the fourth and final lesson of Section 11 of the BJCP training program from the Brewers Anonymous Homebrew Club. We are wrapping up our coverage of yeast and fermentation, and we're going to finish out this section by taking a look at how to control and avoid fermentation byproducts. We are going to start this lesson by looking at esters. Esters are sweet, fruity, or even floral compounds that can be produced by yeast during fermentation. They're mostly associated with ales and ale yeast strains, but it's not only ale yeast strains that can produce esters, and we will discuss that very soon. Ester production can be controlled by the choice of yeast strain, wort gravity, wort aeration, and fermentation temperature. Let's take a little closer look at how each of these different components influence ester production, starting with the choice of yeast strain. Ale yeast strains in general produce higher ester levels than lager yeast strains. Even at that, the amount of esters an ale yeast strain can produce will vary from strain to strain. That's not to say that lager yeast never produce esters. They can produce esters as well if fermentation temperatures are too warm. For the wort gravity influence on ester production, Belgian Trappist ales, now categorized as monastic ales, are a prime example of a style utilizing higher ester production yeast strains in high gravity wort. The higher amount of sugars to metabolize in that wort lends to more ester production. They're further enhanced when adding an ester forward producing yeast strain like a specific Belgian ale yeast strain. Looking at the wort aeration effect on ester production, we already covered that wort aeration is crucial because yeast need oxygen to produce sterols, the compounds that build and strengthen cell walls and support healthy fermentation. However, yeast also create esters through a pathway that competes directly with oxygen absorption by those cells. So if the yeast has enough oxygen early on, it focuses on building strong cells, leading to a balanced ester profile. But if the oxygen is limited, yeast may produce more esters instead, which can increase those fruity flavors in the beer. Looking at fermentation temperature and ester production, on the average, yeast strains, particularly ale yeast strains, as we've been saying, will produce 4 times the amount of esters at 68 degrees Fahrenheit than they will at 60 degrees Fahrenheit. That, of course, is a broad generalization, and there are many exceptions, but in terms of our exam, this is the generalization that we want to be aware of. Now, let's discuss phenols. Phenols can be a combination of spicy, smoky, or medicinal flavors. They can even taste like an old-fashioned cheap plastic Band-Aid in some cases. Phenols are produced by wild yeast strains. With that, the best and most effective way to prevent phenol production is proper and thorough sanitation of all fermentation, racking, and packaging gear. As always, there is always exceptions, and the study guide points out that German wheat beers are the strongest exception to phenols being an undesirable byproduct of fermentation. These beers commonly have a clove phenolic character to them. This specific clove-like character is created by the 4-vinyl glucol phenolic compound. This compound is produced in fermentation when a specific German wheat strain is used when the precursor for this compound, ferulic acid, is present in the wort. Brewers can control the addition of ferulic acid in the wort by producing it during a 111 degree Fahrenheit acid rest step during the mashing process. Next, we've got fusel alcohols, and by fusel alcohols, we mean excessively strong, hot, solvent-like tasting and aroma alcohols. Fusel alcohols are produced when the yeast cells metabolize amino acids in the wort. The production of fusel alcohols increases in high fermentation temperatures. They also increase with high wort gravity. Wild yeast can also produce fusel alcohols in excessive amounts, and they're so strong that they often come across smelling like nail polish remover. In the case of wild yeast and fusel alcohols, proper and thorough sanitization of all fermentation, racking, transfer, and packaging gear is always the best prevention. And lastly, diacetyl. Diacetyl gives a buttery or butterscotch flavors and aromas to the beer with a slick coating texture that lingers in the mouth. For me, diacetyl is an interesting byproduct. It's first created by, but then also removed by the yeast during fermentation. When the yeast first begin to metabolize the sugars and amino acids in the wort, they create the diacetyl precursors and add them to the wort. Once the yeast reach active and continuous fermentation, they convert these precursors to diacetyl. Towards the end of their life cycle and the end of the fermentation process, the yeast start to clean out the diacetyl, converting it to a nearly flavorless compound called butanodyl. We can avoid excess diacetyl production by controlling fermentation temperatures and avoiding the wort's exposure to oxygen. When both of these happen together, that's when the diacetyl is produced to nearly uncontrollable levels for the yeast to clean up. Brewers can control when and how long to have the yeast specifically start cleaning up diacetyl through a diacetyl rest, where the temperature of the wort is raised slightly to reinvigorate the yeast. Diacetyl removal does require yeast contact. It's really the only way to remove it, have the yeast convert it. If we rack the beer from the majority of the yeast too soon or before performing a diacetyl rest, we may be separating the wort from too much of the yeast too soon to be left to clean up the undesirable amount of diacetyl. We did mention this in the bacteria section of Lesson 2, but it's worth repeating in the diacetyl discussion. Gram-positive bacteria can also produce diacetyl in fermenting wort. For that, again, the best prevention is proper sanitization of everything that finished beer is going to touch. All right, we are done with Lesson 4, and we're also done with Section 11. We don't have much more to go in our online exam training material. We're about to dive into the final section of the exam study guide with the beer characteristics, and we're going to have a lot of material to cover in that one, so I'll see you there.